In this video, we're going to try to find an exact expression for phi. What we did in the last class was we divided a Fibonacci by the one before it. We wrote that as f sub n plus 1 divided by f sub n. This would indicate we're dividing one Fibonacci by the one before it, because they go in order, like fn, comma, and then the next one would be fn plus 1. And in looking at these ratios, we found that each Fibonacci was about 1.6 times the one before it. And in fact, as you looked at the ratios approached a number. They became closer and closer to being exactly the same number. And we know that number up to a certain point. We know a few digits, and we could keep going and keep going and keep going and finding more and more digits. But we can't go forever, and we don't know for sure if this decimal might repeat and become a rational number or whether it's irrational. You really can't tell for sure by just looking at these ratios. So in this video, we're going to look at a different approach to looking at these ratios. I wrote the Fibonacci's down at the top here. Notice 144 is the 12th Fibonacci, 233 is the 13th Fibonacci. Make sure that you understand the notation that we use. So now we're going to look at these ratios again. And we're going to look at f2 divided by f1, which is the second Fibonacci divided by the first. And we'll just leave it that way, or if you'd rather, you could just call it 1. Let's look at f3 divided by f2. That will be 2 divided by 1. Now, every single time we know all of these numbers, all of these ratios are going to be bigger than 1. In fact, we know they get to be about 1.6. So each time we do this, we're going to take out a 1, and in this case, it would be 1 plus 1 over 1. And you might be thinking, well, why in the world wouldn't she just write 2? Because I want to show a pattern. And, I know ahead of time what pattern I'm looking for. So all you have to do is bear with me and try to see the pattern. We're not looking for an exact decimal representation of these numbers. We already know what that turns out to be. So let's look at f4 over f3. f4 divided by f3, the fourth Fibonacci divided by the third. Okay, let's take out 1. So 3 halves is 2 halves plus 1 half. 1 plus a half. Now here is where you can start to see the pattern. 1 half, what I have left over here, is the reciprocal of the number before it, which you could think of as 2 over 1, or you could think of as 1 plus 1 over 1. Now, to make sure that you remember what reciprocal means, let's write it. The reciprocal of a number, and I'm just going to make some squiggly, okay? That's some number. I don't care. It could be really complicated. It could have 50 fractions in it. Just a number. The reciprocal of a number is 1 over it. It's just 1 over it. And you're used to thinking of, for example, the reciprocal of 2/3 is 3 halves, but 3 halves is 1 over 2/3 if for some reason you wanted to write it that way. The reciprocal of a number is 1 over it. So keep that in mind as we look at these examples. Okay, we'll continue here. 1 plus 1 over 1 plus a half will be 1 plus 1 over the number before it. And I'll write 1 plus 1 over 1. 1 plus the reciprocal of the number before it. Notice 1 plus 1 over 1, 1 plus 1 over 1. Okay, so f4 over f3 was, as we write here. Let's look at f5. divided by F4. F5 is 5, F4 is 3. 3/3 is 1, and we have 2/3 more, so it's 1 plus 2/3. We see again, it's 1 plus the reciprocal of the number before it, the ratio before it, which I will write as this rather than 3/2. So it is, now listen to my words as I write this. Don't just copy it. This is 1 plus the reciprocal of the number before it, which is circled in red here. I'm just going to copy that number. 1 plus 1 over 1 plus 1 over 1. Look again. This number here is the number before it. So again, 1 plus the reciprocal of the number before it. Similarly, F6, the 6th Fibonacci divided by the 5th, will be equal to 8 over 5, which is 5/5, 1 plus 3/5. And again, 3/5 is the reciprocal of 5/3, or the reciprocal of, well, the reciprocal of this whole thing here was 5/3. So I'm going to write this. I know it begins to look very messy, but it is 1 plus the reciprocal of, and now I'm going to copy what's in the green circle, because that's 5/3. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. And so we see we're getting this pattern, and every single one of these ratios of Fibonacci's to the one before it is going to be able to be written as this fraction containing all ones. Now make sure that you can actually derive one of these yourself. Like, try to get F6 over F5 by yourself so that you see how to draw those denominator lines. Actually, it doesn't take as much mathematical skill, because we're not adding these up or simplifying them, as it does artistic, to be able to see the pattern and copy it. Now, you can see that we can keep doing this forever. And so, that's what these dots right here mean, that we can keep going forever, each time adding 1 plus 1 over the one before it. And so we have another representation for phi, but this time we know what comes next. This time we know what those ... means. In the decimal representation, we had no idea what digits came next. But here we know exactly, because each one will just add another 1 plus 1 over, and you just keep going forever. So this is phi. This is another way to write phi, and we're going to try to use this to find an equation where we can actually solve for phi. This is exactly the same number that I just had in white font. Now I have changed all but the top two ones and the top denominator line to red. It's exactly the same. I just changed the color of the font. And I want you to try to look at that the red part of the number, and tell me, what is that number? This is the tricky, well, actually this whole process is pretty tricky because you've never seen anything like this before. But can you look at that red number all by itself and see what it is? Let me just show you the red number by itself. Here's that red number by itself. Phi was 1 plus 1 over that red number. And notice that that red number keeps going forever. So what is that red number? I'm going to tell you what it is now, so it's a spoiler. If you want to put it on pause and try to think of yourself, what number is it? 1 plus 1 over what? So put it on pause if you don't want me to tell you. And now I'm going to tell you. This is phi. Hopefully you saw that. That red number is phi itself. So we now have a relationship. We know that phi is 1 plus its own reciprocal. 1 plus 1 over phi. And so we can now solve algebraically to find the exact value of phi. Okay, so we had phi is equal to 1 plus 1 over phi. And I'm going to multiply both sides by phi. We know phi is not 0, so I could multiply both sides by phi. When I say sides, I had to put parentheses on there. Phi times phi is phi squared. Well, I want it to change. There we go. Phi squared is equal to, and now use your distributive property and multiply phi across the parentheses, and we get phi times 1 is phi, plus 1 over phi times its own reciprocal is 1. And then subtracting phi and subtracting 1 from both sides, I have phi squared minus phi minus 1 is equal to 0. That means that phi is a solution to this quadratic equation, x squared minus x minus 1 equals 0, which we know, you remember from high school, this has two solutions. And let's recall the quadratic formula. Let me write it down here. And if you don't remember this, that's fine, but you will have seen it before, so it'll ring a bell and you'll believe it. It says that if you have ax squared plus bx plus c is equal to 0, a, b, and c being real numbers, that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So in our case here, we have a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So you go ahead and use this formula here, and you will find that x is equal to 1 plus or minus the square root of, you plug it in and make sure you could, well, make sure that you could get this. 1 plus or minus the square root of 5 over 2. Well, that's two different solutions. That is 1 plus the square root of 5 over 2, or x could be 1 minus the square root of 5 over 2. These are the only two real numbers that satisfy this equation right here. And we know that one of them is phi. We also know many digits to phi. So why don't you take each of those and plug them into your calculator, and you will find immediately which one is our number. It's this one right here. Put that into your calculator, you're going to get exactly the same digits that we got when we were trying to find the digits of phi in last lecture. So this number right here is phi. Phi is called the golden ratio, and we will meet it several times in this class. The golden ratio.